Kita Bbosa science, kwano kwa beti science, dafu ya Bbosa science, truth na beta, truth na omega, truth na alpha science.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding eri abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Dr. Bbosa is a teacher at the Science Foundation College, the best school that teaches sciences. At A-level, we teach sciences only. At O-level, we teach arts and sciences. Today, we are going to study Group 4. Members of Group 4 elements include carbon, capital C, silicon, capital S, small I, germanium, capital G, small e, tin, capital S, small n, lead, capital P, small b. Physical properties of group 4 elements. Carbon and silicon are nonmetals. Germanium is a metalloid. It has got both characteristics of metals and nonmetals. Tin and lead are metals. The general electronic configuration of group 2 elements is Ns2 Np2. The common oxidation states of group 2 elements are positive 2 and positive 4. Stability of oxidation states. Positive 2 oxidation state become more stable down the group, whereas positive 4 oxidation state become less stable down the group. For instance, carbon burns in oxygen to give carbon dioxide in oxidation state 4, whereas lead forms lead 2 oxide. Another example to illustrate the stability of positive 2 oxidation state down the group is that carbon tetrachloride is stable on heating, whereas lead tetrachloride is unstable. It decomposes to a stable lead 2 chloride and chlorine. Lead 4 chloride on heating will give you lead chloride 2 plus chlorine. Reason is for the stability of oxidation states down the group. Oxidation state positive 2 become more stable due to knot pair effect. That is, the 2 Ns electron do not participate in the bonding because the difference between the Ns and Np electrons widens down the group. A case in point, when you look at the outermost electronic configuration of carbon is 2s2 2p2. The energy difference between 2s and 2p is very narrow, so the two electrons can easily participate in a chemical bonding. Whereas in lead, between 6s and 6p2, there are two orbitals, there are two full orbitals in between. So the energy difference between the 6s and 6p is very wide. It is thus possible that 6p may take part in the chemical reaction, leaving the 6s inert. Properties of compounds in oxidation state positive 2. 1. Compounds in oxidation state 2 are predominantly ionic, whereas those in oxidation state 4 are covalent, because formation of positive 4 ions require a lot of energy compared to that forms positive 2 ion. This explains the fact that lead 4 chloride is soluble in ethanol, an organic solvent, whereas lead 2 chloride is insoluble in ethanol. Lead 2 chloride is insoluble in ethanol because it is ionic. Covalent compounds are soluble in organic solvents, whereas ionic solids don't. 2. Compounds in oxidation state positive 2 are reducing. For instance, tin reduce iron 3 to iron 2, whereas while those in oxidation state 4 are oxidizing. Lead 4 oxide on heating will release oxygen. Oxygen added to another compound. That compound is oxidized. Reaction with water. Carbon reacts with steam to form water gas. Carbon plus steam, you get carbon monoxide and hydrogen. Then B, finally divided silicon reacts with steam to form silicon dioxide, but the reaction is limited by the insoluble silicon dioxide. The formation of insoluble silicon dioxide will prevent further reaction. Germanium reacts with steam above 200 degrees to form germanium 4 oxide. Germanium plus water, you get germanium 4 oxide plus hydrogen. The insolubility of germanium 4 oxide limits the reaction. So silicon and germanium, in some books, you can say they don't react with water because silicon dioxide formed and germanium dioxide formed are insoluble in water, will stop further reaction. D, tin does not react with water. Lead reacts with soft water or water containing oxygen to form lead 2 hydroxide. Lead plus water plus oxygen will give you lead 2 hydroxide. Lead does not react with water without oxygen. Reaction with HCl. Carbon, silicon, germanium don't react. Tin liberates hydrogen. Tin plus hydrogen ions, you get tin 2 and hydrogen gas. Lead reacts slowly due to formation of insoluble lead 2 chloride. The formation of lead 2 chloride, which is insoluble, stops the reaction. Reaction with nitric acid. Carbon, silicon, germanium and tin react with hot concentrated nitric acid to form dioxides. Carbon plus nitric acid to form carbon dioxide, nitrogen dioxide and water. Lead reacts with concentrated nitric acid to form lead 2 nitrate. Lead plus nitric acid will give lead 2 nitrate plus nitrogen dioxide and water. Nitrogen dioxide is a brown fume, so you can say that carbon, silicon, germanium, tin and lead react with conc nitric acid to form brown fumes of nitrogen dioxide. 3. With 50% nitric acid, lead reacts to form lead-2 nitrate, nitrogen monoxide, and water. So lead plus dilute nitric acid will give lead-2 nitrate, nitrogen monoxide, and water. So you have to remember to write correct symbols, balanced equation with correct status symbols. Reaction with sulfuric acid. A. Concentrated sulfuric acid. Carbon, tin, germanium don't react with concentrated sulfuric acid. Tin and lead are oxidized. Tin and lead are oxidized to sulfates and sulfur dioxide. Lead plus sulfuric acid will give lead sulfate, sulfur dioxide, and water. The formation of insoluble lead sulfate will stop the reaction or will limit the reaction. The reaction may occur for just a few seconds and stop. B. Dilute sulfuric acid. Carbon, silicon, and germanium don't react with dilute sulfuric acid. Tin and lead liberate hydrogen. Lead plus sulfuric acid, you get lead sulfate plus hydrogen. Lead sulfate is insoluble, so the formation of insoluble lead sulfate limit the extent of the reaction. Some books may then say lead does not react with sulfuric acid because the reaction only occurs for a few seconds and stops due to formation of lead-2 sulfate. Reaction with ethanoic acid. Carbon, silicon, germanium, tin don't react with ethanoic acid. Lead reacts with ethanoic acid in the presence of air to give lead-2 ethanoate and water. So lead plus ethanoic acid plus oxygen, you get lead-2 ethanoate plus water. Reaction with sodium hydroxide. A. Carbon does not react with sodium hydroxide. B. Silicon, germanium, tin react liberating silicate 4, germanes 4, and sternates 4. So an example, silicon plus sodium hydroxide plus water will give you sodium silicate and hydrogen. C. Lead reacts to form plumbants 2. Lead plus sodium hydroxide will give you sodium plumbant plus hydrogen.
And our next dog up in the 8-inch class is Pink, a Papillon handled by Howard Carr of East Falmouth, Massachusetts.
These Papillons in the past have been very, very good in this 8-inch class.
Well, let's see if Howard and Pink can get this party started. Got the turn there. This is a little quick burst of speed right here. Howard gets in front of Pink, makes a nice line right there. Trying to get all he can.
I think people are surprised by how quick and athletic the Papillons are.
You know, you think about the herding breeds and you think about the sporting breeds, but I'm going to tell you, these small dogs, they're athletes. And look at this dog go. You go, Pink.
Trying to beat 39.65.
Contact!
He will shatter it. 34.18 for Pink.
What a
Our last dog up in the 16-inch class is Pink, a border collie handled by Jennifer Crank of Baltimore, Ohio.
Now, Pink is a young dog, not even 3 years old. So, training a dog, only 3 years old, how rare is it to be this good this fast?
It's just like any any rookie. If you think about baseball, sometimes those rookies come up and they just become a phenom.
So this is the Aaron Judge right now of this competition?
Yeah, this is it. This is it. And you can see why with this opening.
Wow.
Look at that speed.
Pink is singing like Pink.
There we go.
Look at that.
Here we go, here we go. Get this turn. Hang in there, hang in there.
Has to beat 31.31.
Woo!
Got it.
I don't think Pink had any trouble.
Uniqueness of carbon. Reason is for uniqueness. Carbon has got very small atomic radius. Carbon has got very small atomic radius. Carbon has high electronegativity than any other element in group 4. Carbon lacks accessible d orbital in its valence shell. Unique properties of carbon. Carbon forms gaseous oxides, whereas other elements form solid oxides. Note that carbon dioxide is a gas because in solid form its molecules are held by weak van der Waals forces. Silicon dioxide has very high melting point because each silicon atom is bonded to 4 oxygen atoms by strong covalent bonds. The strong covalent bonds require high temperature to break. 2. Carbon tetrachloride and carbon tetrahydrides do not hydrolyze in water due to lack of accessible empty d orbitals. Chlorides of other elements hydrolyze in water, liberating HCl. HCl fumes in moist air, so we can say that chlorides of other elements fume in air due to production of HCl. 3. Carbon forms compounds mainly in oxidation state, positive 4. Other elements form compounds with oxidation states positive 2 and positive 4. 4. Carbon forms compounds with chains, rings, branches, while other elements don't. Number 5. Carbon forms carbon tetrafluoride but cannot form carbon hexafluoride. Allotropes of carbon. Carbon exists in 2 main allotropes, that is graphite and diamond. Structure of graphite. In graphite, each carbon atom is bonded to 3 carbon atoms to form a layer of hexagonal ring. Each layer is bonded to another by weak van der Waals forces. Properties of graphite. Graphite has got a low density compared to diamond because its structure is open. 2. It is slippery due to weak forces between its layers. And 3. Conducts electricity due to free unbonded pi electrons. Each carbon uses a free electron of the 4 in the bonding, then the 4th electron In the valence shell, the main is free to conduct heat and electricity. Diamond. In the diamond, each carbon atom is bonded to 4 carbon atoms by strong covalent bonds. Properties of diamond. Diamond has got very high melting point and boiling point. It has high density. It is the hardest substance known. It is used as ornament. It is used to make drills and to cut other substances. Differences between graphite and diamond. The density of graphite is 2.3 grams per centimeter cubed. The density of diamond is 3.5 grams per centimeter cubed. Graphite is soft. Diamond is very hard. Graphite is slippery. Diamond is not slippery. Graphite conducts electricity. Diamond does not conduct electricity.
Omukyala kyakufumbira kyolya, omukyala kyakufumbira kyolya, naye lwaki mono ku muntu womala kuyomba, mono ku muntu womala kulwana, mono ku muntu wotujereka, lwaki wangana okulya mu kyalo, lwaki woza simalako olimba, olusi wogifumbira waba kulwaza, olusi wogifumbira waba wakyamu, omulungi atanabakanyiwa n'obutayoza kiba kikyamu, entikko y'omukwano kisenge, lwaki naye lwaki mono ku muntu womala kuyomba, mono ku muntu womala kulwana, mono ku muntu wotujereka, lwaki wangana okulya mu kyalo, ofumba obwagala lisaaki okunyuma, wange ensiba mu lisaaki, mondo okumukuta ndwawo, mondo okumunyima ntabuka, mondo okumuzima kuba, mondo okuwomerwa kiva ku mazzi, wetegekere muno, nfunira akaseera akamala, ozanyisa omutwe ogwanyumirwa, wagazanyisa mipiira anyumisa, zanyisa baluni, zanyisa amabeere, lusinyoka n'okuyonka anyumirwe, faayo omukwano gwagala kuyiya, ofumba obwagala lisaaki okunyuma, wange ensiba mu lisaaki, bweruba oluganda nsobola okuwasa omukyala abawo, njagala omukyala abawo, betita yombayomba, betita nyiganyiga, betita ganagana, bw'oyagala akawunga abawo, bw'oyagala omuceere abawo, ennyimba z'omupiira asobola, anyumisa, nyumirwa omukwano gwe, mono ku muntu womala kuyomba, mono ku muntu womala kulwana, mono ku muntu wotujereka, lwaki mono ku muntu womala kuyomba, mono ku muntu womala kulwana, mono ku muntu wotujereka, lwaki